When people think of supervolcanoes, Yellowstone often steals the spotlight with its dramatic geysers and apocalyptic reputation. But what if the next major volcanic threat isn't across the Atlantic, but lurking in Europe's own backyard? Campi Flegrei, a sprawling volcanic caldera near Naples, Italy, is quietly simmering, and its potential reach could extend far beyond Italy's borders. With recent seismic swarms and alarming ground uplift, this hidden giant is raising concerns among scientists and locals alike. Could Campi Flegrei redefine our understanding of continental threats? Let's uncover the dangers of this supervolcano and explore its potential to impact not just Italy, but the entire European continent. Europe's hidden giant. An introduction to Campi Flegrei. What is Campi Flegrei? Unlike the iconic cone-shaped silhouette of Mount Vesuvius, Campi Flegrei, or the Phlegrean Fields, doesn't look like a typical volcano. It's a massive 13-kilometer-wide caldera, a vast depression formed by the collapse of the Earth's surface following two colossal eruptions, the Campanian ignimbrite about 36,000 years ago and the Neapolitan yellow tuff around 15,000 years ago. This caldera, partially submerged beneath the Gulf of Pozzuoli and stretching into the bustling city of Naples, is Europe's largest active volcanic system. It encompasses 24 craters, gassy fumaroles, bubbling mud pools, and a population of over 360,000 people living directly atop it, with 2.3 million in the surrounding area. Campi Flegrei's history is marked by violent eruptions, with its most recent in 1538 creating the Monte Nuovo cinder cone after decades of uplift. Unlike stratovolcanoes like Vesuvius, which often provide clearer signs of impending eruptions, calderas like Campi Flegrei are notoriously unpredictable, making them harder to forecast. The region's dense population and proximity to Naples make it one of the world's most hazardous volcanic zones. Recent seismic activity and ground uplift. Since 2005, Campi Flegrei has been in a state of unrest, characterized by a phenomenon known as bradyseism, slow, cyclical uplift, and subsidence of the ground caused by pressure changes in magma chambers or hydrothermal systems. The current phase of positive bradyseism, where the ground is rising, has intensified since 2022, with uplift rates reaching 2 cm per month in some areas. In 2024 alone, the region recorded 6,740 earthquakes, a stark increase from previous years, including a seismic swarm of 150 quakes in just 5 hours on May 20th, 2024, with a magnitude 4.4 event, the strongest in 40 years. Ground uplift in Pozzuoli, the epicenter of the caldera, has reached approximately 1.3 meters since 2005, with 2 rapid uplift events in recent months adding over 15 millimeters of vertical displacement. This deformation, combined with a super-exponential rise in seismic energy release, suggests the caldera's crust is undergoing significant stress. Scientists are particularly concerned because the uplift is stretching the crust, potentially weakening it and increasing the likelihood of fault ruptures. These signals have prompted heightened monitoring by Italy's National Institute of Geophysics and Volcanology, INGV, which tracks seismicity, ground deformation, and gas emissions through an extensive network of seismic, geodetic, and geochemical stations. The Solfatara crater, a key feature of the caldera, is emitting 5,000 tons of CO2 daily, comparable to burning 500,000 gallons of gasoline, placing Campi Flegrei among the world's top volcanic CO2 emitters. These indicators point to a restless system, but whether this unrest will lead to an eruption remains uncertain. The mechanisms behind the unrest. Bradyseism and its drivers. Bradyseism, derived from the Greek for slow earthquake, is a hallmark of Campi Flegrei's activity. It results from pressure changes in the shallow subsurface, driven by either magma ascent or hydrothermal activity. Recent studies suggest that the current unrest is primarily caused by rising pressure in a capped geothermal reservoir beneath Pozzuoli, rather than solely magma movement. This reservoir, sealed by a self-healing caprock, traps water and vapor, leading to ground deformation and seismic activity as pressure builds. However, petrological and geodetic data indicate that magma ascent from depths of 8 kilometers to shallower levels, 3.9 to 5.9 kilometers, is also contributing to the inflation. The interplay between hydrothermal fluids and magma creates a complex system where pressure can trigger steam-driven explosions, especially during seismic fracturing. This dual mechanism, hydrothermal and magmatic, complicates predictions, as the absence of significant new magma incursions, based on gravity field measurements, doesn't rule out the potential for an eruption. Seismic swarms and crustal weakening. The exponential increase in earthquake frequency and energy release since 2020 is a critical concern. Seismic swarms, like the one in May 2024, are driven by stress concentration on pre-existing fault zones within the caldera. High-precision earthquake relocations from 2014-2024 reveal active fault zones, including the inner caldera ring and faults around the Solfatara crater, with some newly identified structures in the eastern sector. These faults could accommodate earthquakes up to a moment magnitude of 5.1, significantly raising the seismic hazard. The crust's quasi-elastic behavior, where it stretches with subordinate faulting, is transitioning toward inelastic deformation, where fracturing dominates. This progressive weakening, observed across uplift episodes since the 1950s, suggests the caldera is approaching a critical threshold where a rupture could open pathways for magma or trigger larger quakes. Campi Flegrei's immediate threat lies in its proximity to densely populated areas. Over 360,000 people live within the caldera, and 2.3 million reside in the broader region, including Naples. The red zone, encompassing 18 towns like Pozzuoli, Bacoli, and Quarto, is at the highest risk for pyroclastic flows, fast-moving avalanches of hot gas, ash, and volcanic debris. An eruption, even a small one, could be catastrophic due to the population density. Seismic activity alone poses significant risks. The 1982-1984 crisis saw 1,300 monthly earthquakes and uplift rates of 9 cm per month, leading to the evacuation of 40,000 people from Pozzuoli after a magnitude 4.2 quake. Current seismic swarms have caused minor structural damage, such as cracks in walls and falling cornices, but a magnitude 5.1 event could severely impact buildings and infrastructure. Evacuation plans estimate 72 hours to move 500,000 people from the red zone using buses, trains, and boats. However, experts like INGV researcher Giuseppe Mastro Lorenzo argue that these plans are inadequate, as caldera eruptions can occur with little warning, unlike stratovolcanoes. The 1538 eruption, preceded by decades of uplift, occurred rapidly, suggesting a similar event could overwhelm current preparations. An eruption or prolonged seismic crisis could devastate the region's economy. Pozzuoli's port, already affected by uplift that has rendered it too shallow for docking, is a critical economic hub. Naples, a major cultural and tourist destination, relies on the region's fertile volcanic soil for agriculture, producing Vesuvian apricots, figs, and wines like Falangina. Disruption from ashfall or infrastructure damage could cripple these industries. Culturally, the region's historical sites, such as the Roman Temple of Serapis in Pozzuoli, which bears evidence of past bradyseismic cycles, could be at risk. The submersion of Baia, a Roman town, due to long-term subsidence, highlights the caldera's power to reshape landscapes and erase heritage. While a small eruption might be confined to southern Italy, a larger event could have far-reaching consequences for Europe. Campi Flegrei's past super-eruptions, like the Campanian ignimbrite 36,000 years ago, ejected massive volumes of ash and aerosols into the atmosphere, potentially causing regional climate cooling. A modern eruption on this scale could disrupt air travel across Europe, as seen during the 2010 Eyjafjallajökull eruption in Iceland, which grounded flights for weeks. Ashfall from a significant eruption could blanket parts of Italy, France, and the Balkans, depending on wind patterns. The yellow zone, home to 800,000 people beyond the red zone, would face heavy ashfall, requiring temporary evacuations and causing respiratory health risks. Beyond Italy, ash could affect agriculture in southern Europe, contaminating crops and water sources. Campi Flegrei's location along the Tyrrhenian Sea raises concerns about tsunamis. Models suggest a major eruption could trigger a 100-foot tsunami, impacting coastal areas like Pozzuoli, Sorrento, and even distant Mediterranean shores. Such an event could affect ports, shipping routes, and coastal communities across southern Europe, with economic ripple effects for trade. The transboundary nature of a potential eruption underscores the need for European coordination. Unlike Yellowstone, which is relatively isolated, Campi Flegrei's proximity to major urban centers and international borders demands a regional response. The European Union's Copernicus Land Monitoring Service already supports ground deformation tracking. But a comprehensive disaster response plan involving neighboring countries is lacking. Countries like France, Greece, and Croatia could face indirect impacts from disrupted trade, tourism, or ashfall, necessitating preemptive planning. Campi Flegrei is one of the world's most monitored volcanoes, with INGV's Vesuvius Observatory employing seismic, geodetic, and geochemical stations, complemented by satellite data from the CNR-IREA. Seismic noise interferometry tracks subtle velocity changes in seismic waves, indicating fluid movement at shallow depths, while gas analyses at Solfatara reveal increasing hydrothermal activity. These tools provide critical data, but the volcano's complexity limits definitive eruption forecasts. Recent research suggests managing groundwater levels or channeling surface runoff to reduce pressure in the geothermal reservoir, potentially mitigating seismic activity. Structural retrofitting of buildings to withstand quakes up to magnitude 5.1 is underway, but the region's dense urban fabric poses challenges. Long-term strategies include improving evacuation plans and public awareness, as many residents underestimate the risks due to the volcano's unassuming appearance. While the probability of an imminent eruption remains low, the relentless uplift and seismic activity suggest Campi Flegrei is awakening. Scientists emphasize that even a crustal rupture may not lead to an eruption, but the potential for significant seismic events persists. For Europe, the challenge lies in balancing vigilance with practicality, ensuring that Italy and its neighbors are prepared for a range of scenarios, from localized quakes to a rare but catastrophic super-eruption. Campi Flegrei is a stark reminder that Europe's volcanic threats extend beyond the iconic Vesuvius. Its hidden nature, combined with its proximity to millions of people, makes it a unique and pressing concern. The caldera's recent unrest, marked by intense seismic swarms, ground uplift, and hydrothermal activity, signals a system under stress, with implications that could ripple across the continent. From disrupting air travel and agriculture to triggering tsunamis and economic losses, a major event at Campi Flegrei could test Europe's resilience. By understanding this unseen giant and investing in robust monitoring and preparedness, Europe can mitigate the risks of a threat that, while dormant for now, is far from asleep.